Alrighty, welcome to our last lesson before our mid-unit in Unit 6. And so we're going to talk a little bit about equivalent quadratic expressions. So this lesson actually is the beginning of our next section, but we're going to start at least exploring what this looks like initially. So the goal of today is to use diagrams to help us rewrite quadratic expressions. And so what diagrams are we using? So back to our basics elementary school using the distributive property. So the distributive property is multiplying the sum of two or more addends, right? Two things you are adding together by a number will give us the same result as multiplying each addend individually by the number and then adding the products together. And so here's a visual representation of that, right? The a times b plus a times c is the same thing as a times b plus c. And so we have our options, our options. So you can either do a times b plus a times c, or b plus c first and then multiply it by a. And so that is our distributive property, right? Think about the arrows that we used to draw, right? A times b times a times c. And so what you just saw on your last slide was what we call an area model. And so an area model is a rectangular diagram that is used to multiply and divide two numbers or expressions. And so let's take a look at what that represents. And so in the warm-up, I want you to explain why the diagram shows that 6 times 3 plus 4 is the same thing as 6 times 3 plus 6 times 4. And so our big rectangle is 6. Think about the area of a rectangle. Length times width. My length is 3 plus 4, right? 3 plus 4. And my width is 6. And so you could actually summarize that down. 3 plus 4 is 7. So our width is area of our rectangle is 7 by 6. And so the one way of thinking about it is 6 times 3 plus 4. Another way of thinking about it is 6 times 3, which is your first rectangle, and 6 times 4, which is your second rectangle, right? Sometimes it's easier to take the area of the parts rather than the whole. And so you can think about it as 6 times 3 times 6 times 4 plus 6 times 4, right? Giving me my total area, right? Addition, my total area. 6 times 3 plus 6 times 4. And so I want you to, in the warm-up, draw a diagram that shows that 5 times x plus 2 is equal to 5x plus 10. And so draw the same diagram that I had. Give me each of your numbers. It's not going to be 6, 3, and 4. What are the three numbers going to look like? And then show me just by writing out, just as I did in this video. The next part is applying the distributive property a little bit deeper. And so apply the distributive property to multiply out the factors or expand factors of x to expand 4 times x plus 2. That gives us 4x plus 8. We know that the two expressions are equivalent. Remember, equivalent are two expressions that have the same solution. We can use rectangles with side lengths x plus 2 and 4 to illustrate this multiplication. I want you to draw a diagram to show that n times 2n plus 5 and 2n squared plus 5n are equivalent expressions, and I'll do that with you. For each expression, use a distributive property to write an equivalent expression. If you get stuck, consider drawing a diagram. I always suggest drawing a diagram. You can use a distributive property, but I suggest using a diagram as well. So, number 1. My left side is n. My 2 up 2 are 2n plus 5. And so 2 times n is 2n times n is going to give me 2n squared, right? I have two factors of n. 5 times n is going to give me 5n. So in total, I have n times n. 2n plus 5 is the same thing as 2n squared plus 5n. Right, here's the beginning part. And I want you to do the same thing for each of the following expressions. Back there, sorry. And so, yep, all of number 2. Right, draw out your diagrams, distribute a property. Well, really the new part here, because the first two parts are really warm-ups. You've really been doing that distributive property since middle school, since actually elementary school, really. And so what's new here is understanding how to multiply quadratic expressions. And so here's a diagram of the rectangle with side lengths x plus 1 and x plus 3. Use this diagram to show that x plus 1 times x plus 3 is the same thing as x squared plus 4x plus 3 are equivalent expressions. And I want you to do the same thing for the equivalent expressions for the following below. So, first example, Same thing. You're going to take your two numbers, number from the top, number from the left. X times x gives me x squared. 3 times x gives me 3x. X times 1 gives me x. 3 times 1 gives me 3. Right? Do you see at each point I am x times x, right? And then x times 3, right? Do you see how we're just pulling from each of those values? 1 times x, and then 3 times 1, right? Do you see how we got each of those numbers from our value? And so when we put it all together, we have x squared plus 3x plus x plus 3. But we're not done yet because we have two terms that are similar to each other that I can combine together. 3x and x are what we call, like I said, like terms. They each have one value of x, and so I can combine them into x squared plus 4x plus 3. And that's exactly the same as what we had at the top, and that's what we were looking for. And so I want you to do the same thing for number 2 as well. To give you a hint for what letter A, x plus 5 squared is the same thing as saying x plus 5 times x plus 5. So what I want you to do is draw yourself a little diagram like these. Give yourself, right, x plus 5, and do the same multiplication that we've been doing before. And so I'll give you another example as well as we're going through. So one more example is with negative numbers. Right, my first one was x times x is x squared. My second one was x times x is just x. But what happens when I have a negative 3? Just treat this as normal multiplication. Right, the area of this rectangle is x times negative 3, which is just negative 3x. And then once again, negative 3 times 1 is negative 3. And so same thing when you're adding together, x squared minus 3x plus x minus 3. Put it together, x squared minus 2x minus 3. And so this is the same thing. Don't get nervous when it is exponential functions. Just multiply that negative number. A negative times a positive is still going to be negative. And so negative 3 times 1 is negative 3. Negative 3 times x is negative 3. And so in your homework, just practice. Draw those diagrams out. Make it easy for yourself. We'll be practicing it more together in class. But your goal of today is you can rewrite quadratic expressions in different forms by using the area diagram or the distributive property. And so we'll explore this together. Like I said, this new lesson is introduction to what comes next, but it also wraps up our first half of our unit. So I look forward to seeing you there.